Today we're going to talk about section 5.3, solving quadratic equations by finding square roots. Before we get started, let's talk about the different parts that we're going to work with. This thing, you guys usually call it a square root sign. It's actually called a radical sign. That little check mark thing. Inside the radical sign is the radicand, the number we're taking the square root of. And this whole thing all together. So I'm talking about the square root of n here. That whole thing is a radical, or a radical expression. However you want to refer to it is fine. So if I talk about the radical or the radicand, radical sign, either way, that's just so you guys kind of know what I'm talking about when I'm talking about these different parts. A couple properties of square roots before we get going too quickly here. We've got the product property. So if I have the square root of AB, I can take the square root of A times the square root of B. Meaning, if I look at the square root of 20, I can break that down to two numbers that multiply to 20, square root of 4 times the square root of 5. And the reason I picked 4 and 5 is 4 is a perfect square, so the square root of 4 is 2 times the square root of 5. So just an example for you. That's kind of how we would use that, helping us simplify those radicals a little bit. Then the quotient property, the exact opposite, well, not really the exact opposite, but if I'm taking the quotient of a fraction, I can take the square root, or if I'm taking the square root of a fraction, I can take the square root of the numerator and the square root of the denominator separately. So if I look at the square root of 4/9, means I can take the square root of 4 over the square root of 9, which is going to give me 2/3. Square root of 4 is 2, square root of 9 is 3. So we're going to use those to help us simplify some fraction or some radicals a little bit. You know, being able to simplify is one of the things that we're going to need to be able to do here. So today we're going to take a look at trying to simplify the expression the square root of 24. What you want to do with these is try and find the biggest perfect square that you can find. So, like 2 squared is 4, 3 squared is 9, 4 squared is 16. You want to try and find those numbers that are going to give you perfect square roots. So, square root of 24. Well, I know 24 is 4 times 6. So, from our product property, I can take square root of 4 times the square root of 6, and I can get 2 times the square root of 6, or just 2 square root 6. Either way, it's the exact same thing. So don't do like 2 and 12. That's not going to help you out a whole lot. Breaking down 6, factors of 6, 1 and 6, 2 and 3, not going to help us out much since none of those are perfect squares. So we just leave it as 2 square root 6. Now, for B, we're going to use our product property in reverse to make it a little easier for us. So we're going to take the square root of 6 times the square root of 15. 6 times 15 gives me the square root of 90. Now what I'm going to do is I'm going to reuse that product property, and find a perfect square within 90. Well, 3 squared is 9, so I'm going to take the square root of 9 times the square root of 10, which the square root of 9 breaks down into 3 square root of 10. Moving on, we've got the square root of 7/16. Well, our quotient property tells us that I can go with the square root of 7 over the square root of 16. 7. It's not a perfect square. Nothing squared is 7. But can I break it down using some perfect squares? Nope. So I'm just going to leave that as the square root of 7. Square root of 16 I know is 4. And I can just leave this right here. Okay? Square root of 7 over 4. Now, if I look at D, same idea. We're going to use that quotient property. I'm going to take the square root of 7 over the square root of 2. Well, neither one of these are perfect squares. So why am I showing this to you? Well, we've actually got a problem with this. Within this problem, mathematically, you can't have a square root in the denominator. So we're going to use some properties of square roots. We're going to use some properties of fractions, properties of square roots. I need to multiply by the square root of 2 in this case over the square root of 2. The reason I do this, if I take the square root of 2 times the square root of 2, that's going to give me the square root of 4. And the square root of 4 is just 2. And then I can take the square root of 7 times the square root of 2 to get the square root of 14. So, square roots are okay up in the top. Up in the bottom, we've got a problem. So, if you've got just a single square root like this, you're okay to just multiply by that same square root. And I multiply by the same thing on top and bottom, because since I have a fraction that is the same on top and bottom, this is just equal to 1. So by multiplying by 1, I'm not changing anything. So just one of those little tricks that they can use to get you something to be aware of. So what are we going to do? How are we going to solve problems like this today? Well, if I've got 2x squared plus 1, this is going to start very much like your typical algebra problem where you're trying to get x on one side by itself. So I've got 2x squared. I'm going to subtract 1. Subtract 1. I get that 2x squared is equal to 16. Now, I divide both sides by 2, and I get x squared is equal to 8. And now, how do we undo squaring? Well, squaring and square roots are the exact opposite of each other, so they undo each other. So, we get that x, just regular x, is equal to the square root of 8. One thing you guys need to be aware of, anytime you put the square root in the problem, so I put this square root of 8 in there, you need to have plus or minus in front of it. The reason being, say off to the side here, I'm just going to work a little example. So, say I had the square root of 16. Well, everybody, so far, since we've been given these, we've just taken them as all positive. So, we say that's 4. But is there another number times itself that would give me a positive 16? Well, last time I checked, negative 4 times negative 4 equals 16. So, this plus or minus in red by our 8 takes into account that we could have a positive times a positive, or a negative times a negative. Since it's the same thing, you need that plus or minus. And now we just have to simplify the square root of 8. Well, we get that x is equal to plus or minus. Are there any perfect squares in here? Yes, square root of 4 times the square root of 2. So x is going to be plus or minus 2 square root 2. And that's our answer. Then we're going to solve 1/3 times x plus 5 squared is equal to 7. So, again, so you want to get this squared term, this guy, in this case, is going to be the full x plus 5 on one side by itself. Well, how am I going to get rid of that 1/3? Well, to get rid of fractions, you multiply by the reciprocal. So, instead of dividing by 1/3, we're going to multiply by 3 on both sides. So, 1/3 times 3 is just going to leave me with x plus 5 squared is equal to 21. And now, a lot of people want to subtract this 5 here for their next step. Can't do that. It's trapped inside that squared term. So we have to get rid of this squared before we can do anything. To undo squaring, we take the square root of both sides. Okay? I just put the square root in. So on the right side, I'm going to have, I need to have that plus or minus 21. On the left, I've got x plus 5 is equal to that should be a square root, sorry. So I have x plus 5 is equal to plus or minus square root 21. Now you can move your 5, subtract 5, subtract 5. And square root 21 does not come out to be a nice number. So you're going to plug it into your calculator, get a nice decimal, but it's going to just keep going for forever and ever. So just leave it as a square root of 21, and you're going to have x is equal to negative 5 plus or minus the square root of 21. This is where I would really leave it. Some people don't like it in that form because they don't like that plus or minus. What that really means is that x is equal to negative 5 plus the square root of 21, or x is equal to negative 5 minus the square root of 21. That won't come into play a whole lot unless you get like a perfect square. So if I had like negative 5 plus or minus the square root of 16, find the square root of 16. That's an easy number. It comes out nice for you. So you'd have negative 5 plus 4, and you would get negative 5 minus 4, and you guys could simplify that and get two numbers for me. Let me know if you guys have questions on any of this. I will be happy to help you with any of this. And I will see you in class. We'll work on these next time I see you.